Good morning, children. Today we will be doing the numericals on first order reaction. One numerical is there. A first order reaction is found to have a rate constant K is equal to 5.5 into 10 to the power minus 14 per second. Find the half-life of the reaction. So, the solution is the reaction is of first order. First of all, you have to write in this way whether the reaction is of first order or zero order. Now, K is equal to 5.5 into 10 to the power minus 14 per second, and T half is being asked, half-life. T half is being asked. Since the reaction is of first order, so we can very well write T half is equal to what? 0.693 by K is equal to 0.693 by 5.5 into 10 to the power minus 14 per second. This equals to 1.26 into 10 to the power 13 seconds. So it can be given in this way. T half time period is given and K is being asked. So let us do the another numerical. A first order reaction. Is it clear to you? Question number 2. A first order reaction is 40% complete. A first order reaction is 40% complete. In 50 minutes. In 50 minutes. Calculate the value of rate constant. Calculate the value of rate constant. Rate constant in what time will the reaction? In what time will the reaction be 80% complete? Now look at this. The reaction is of first order. Here it is given that 40% of the completion of the reaction takes place in 50 minutes. You have to calculate the value of rate constant K, and then you have to find out the time for which 80% of the reaction gets completed. So the solution is, first of all you have to write the reaction is of first order. The reaction is of first order. Now since two parts are there, so let's go for completion of 40% of the reaction. Here let us take that the initial concentration of A is equal to 100, then molar concentration of A in 50 minutes, that will be equals to what? Since 40% is completed, so how much is left? 100 minus 40, that equals to 60, and T is equal to 50 minutes. We have to find out K, question mark. The reaction is of first order, so K is equal to 2.303 by T into log A naught by A. Substitute the values. 2.303 by time is your 50 minutes into log 100 by 60. 2 5s are 10, 2 3s are 6. So we are having 2.303 by 50 minutes into log 5 minus log 3. Log 5 minus log 3. Here it is your 6 log 5, the value is 6990. So we will be putting in this way 2.303 by 50. Since 50 is here, you can multiply 2 by 2 to get 100. 2 into 50, 100, and here will be 0.6990 minus 0.4771. Characteristic 0, and the value of log 50 will become 6990, and then like that. From the log table you can go for. Log 5 is not there. You have to take the help of log 50. Log 3 is also not there. You have to take the value of log 30. Now coming to, it will be your 4.606 by 100. Here is your minute into, the subtraction is your 0.2219. 0.2219. That minute per minute will become minutes. Now it is your, multiply these two, it will become 1.022 into 10 to the power 2 minutes. So the value of K is your 1.022 into 10 to the power 2 minus 2 per minutes. Now the other part is for completion of how much? 80% of the reaction. Let's go for that. For completion of 80% of the reaction. Initial molar concentration, let it be your 100. Then molar concentration of A will be equals to what? 100 minus 80, that equals to 20. Why? Because 80% of the reactants have been consumed. Now how much is left? 20% is left. Now it is your T is being calculated, to be calculated. So we are having T is equal to 2.303 by K log A naught by A. Another thing is, we can go in this was 2.303 by, put the values of K. The value of K is a 1.022 into 10 to the power minus 2 minute. The value of K is per minute. So it will be log 100 by 20. This equals to 2.303 by 1.022 into 10 to the power 2 minutes into log 5. Log 5. This equals to, you divide this to 2.303 it becomes 2.253 into 10 to the power 2 minutes into 0.6990, the value of log 5, and this into this, you multiply it, you will get 1.5748 into 10 to the power 2 minutes. Is it clear? Now go for another numerical. It's your NCERT, it is of NCERT book, and from the exam point of view it's very important because many times it came in the board exam. The question is, so that in case of a first order reaction, in case of a first order reaction, the time required for time required for 99.9% of the reaction to take place, is about 10 times than that required for half of the required for half of the reaction. Look at that. So that in case of a first order reaction, so reaction is a first order, the time required for 99.9% of the reaction to take place is approximately equals to 10 times than that required for half of the reaction. Half of the reaction. Let's go for. Again we have to write the reaction is of first order. The reaction is of first order. So we will be doing this numerical in a different way. I think in a more easier way. Look at that. T is equal to what? T is equal to 2.303 by K log A naught by E. This is the formula. So T 99.9%. What does it mean? The time required for the 99.9% completion of the reaction is equal to, take the help of this, 2.303 by K log. It is, if it is your A naught is 100, then what will be A? 100 minus 99.9, because 99.9% have been consumed. So this equals to 2.303 by K log 100 by 0.1. This becomes equals to 2.303 by K log 1000. This equals to 2.303 by K log 1000 is 3. Log 1000 is 3. Now T half is equal to what? 0.693 by K. Already we have derived in the previous class. This equals to, we will convert this one into in terms of 2.303. 2.303 by K into 0.3010. Let it be 0.301. Okay. Now we can write T 99.9% by T half is equal to what? Substitute the values. This one. This value. 2.303 by K into 3, and here will be 2.303 by K into 0.301. This gets cancelled. So here will be what? Into 1000. So is equal to what? Approximately. Here will be 3000 by 301. So T 99.9% is equal to, this value is your approximately 10. Approximately 10. So will be equals to 10 into T half. So in this way, if we will take the value of T half as 0.693 by K, the calculation is a bit lengthy. But if this one is converted into 2.303 by K log 2, which is your 0.3010, then these two gets cancelled and we get the answer. So I hope it is clear to you.